This is the second in a series of lectures dealing with motion in a plane, an XY plane. For the remainder of this chapter, we will be dealing with a special type of motion in a plane. It will be motion in a vertical plane, not a flat surface laid horizontally, but a vertical plane. And that type of motion that we're going to consider is called projectile motion. A projectile is an object that is thrown, fired, shot, kicked, or swatted. It has no propelling device attached to it, such as a propeller or a rocket engine. It's flying only under the influence of the pull downward by Earth, under the influence of the gravitational force, which we'll discuss in a later chapter. You've already seen equations that relate to motion in two dimensions, as we sometimes say. Motion in which there's an x part and a y part, or an x component and a y component. We're going to restrict our attention, as I said, to projectile motion, in which the equations that we use are simpler than the ones that we put to use when we first looked in the previous video lecture at motion in a plane. The equations I'm referring to that we looked at then are shown here. The future x coordinate of an object is given by that equation, which involves the x component of the initial velocity, v0, and the x component of the object's acceleration. A similar equation is related to the one above. Everywhere you see an x, 1, 2, 3 places, put a y, 1, 2, and 3. Other equations deal with the future x component of velocity, v sub x. It's the x component of the initial velocity plus a sub x times t. A sub x being the x component of the acceleration. And then finally there was the future y component of the velocity, v subscript y, equaling the y component of the initial velocity plus a sub y, the y component of acceleration, times t. Well, let's go back upstairs. In everything that will follow in this chapter that will deal exclusively from now on with projectile motion, the x component of the acceleration of our object will be 0. There will be no change in the x velocity. In other words, a sub x 0 means v sub x does not change. Whatever it once was, it'll always be. With a sub x equal to 0, this equation loses that term, and we end up with this equation in the red box, which I've labeled out of order equation number 3. Down to this equation, it'll be the case from now on that our y component of acceleration will always be negative 9.8 meters per second per second. Negative g, in other words. So this equation is modified slightly. Replace this term with minus 1/2 g t squared. Equation 4. The future x velocity equation, when a sub x is set equal to 0, we lose that term, and we see that v sub x is equal to the x component of the initial velocity. V sub x is the x component of the velocity at any future time. And so this equation asserts that the x component of the velocity of our object is a constant. It does not change. Whatever it once was, it'll always be. And finally, this equation becomes this one when we replace a sub y with negative g. equation 2. Equations 1, 2, 3, and 4 are the only equations you'll need for the remainder of this chapter that will deal exclusively with projectile motion. In our next video lecture, we'll look at the behavior of these expressions, these equations, and study how the y velocity changes as time goes by, and note that the x velocity does not change. So let's end this video lecture now and get ready to look at the next one dealing with the topics I just mentioned.